Hello, everybody. My name is Josh Ellithorpe. I'm here presenting about what OpenStack is in a hybrid world. And today, a lot of organizations are looking to extend out into public clouds or connect their private clouds. So what does that mean? And what does that mean in relation to the OpenStack installations people are deploying today? You can find me on Twitter, ZQuestZ on Twitter, and I work for Apsera out of San Francisco. So first, I'm going to define what I consider true hybrid. First, that means support for both public and private clouds, AWS, GCE, Azure, OpenStack, VMware, ESX-based products on vSphere, as well as bare metal installations. All of these different environments need to be able to work together. It means full mesh networking, which means that service availability needs to be able to work across the boundaries of your different hybrid environments. So if you're using Swift in OpenStack and you're transitioning over to AWS, you shouldn't have to redo all of your infrastructure and move everything to S3 immediately. You should have access to your data stores that were sitting on OpenStack and be able to treat those as first-class citizens, making it much easier for you to move your data later. It means that you can move your applications and worry about data services when it's convenient and not have the level of vendor lock-in that you have in today, and to be able to have completely portable workloads. And what that means is, if I deploy something to OpenStack today, I should be able to move that to AWS or GCE or some other cloud environment within seconds. And it should run exactly the same way that it ran, with the same security guarantees, same packages on another cloud, just like it was running a few minutes ago on OpenStack. And there should be a policy system that is ingrained at the very base of your platform. You should have policy controls around resource management, what services can be connected to, and that one policy system should be able to govern all the different parts of your hybrid environment. Every cloud should be able to respect that policy and adhere to that policy so that you're not having to go in and configure different security situations for every single cloud that you're deploying to. So I told you that I'm from Apsera. We're a startup based in San Francisco, founded by the architect of Cloud Foundry, Derek Collison. We are the developer of Apsera's Hybrid Cloud OS, which we are actually demoing on the show floor today. And we're building the most secure enterprise-grade container deployment system in the world. We deploy Docker containers, as well as our own container runtime. And we actually work very closely with CoreOS and other container vendors to make sure that we have the best compatibility in the market. We also have an amazing team of developers with DNA from Google, VMware, Oracle, TIBCO, and a bunch of other larger enterprises with a lot of experience in what enterprises need today to truly move to these public cloud environments. So today we announced a bunch of partnership arrangements with Mirantis, and on the show floor we are actually demoing our hybrid cloud operating system. It's running on Mirantis Express and leveraging several of Mirantis' key technologies, including their VPN as a service technology, which is connecting to GCE and Amazon. And what is unique about that is that's only one piece of the equation. Connecting OpenStack to these different clouds is always really good, and making sure that you can deploy your workloads to AWS, but you also need the interconnectivity between the cloud vendors themselves. So you need direct connections from AWS to GCE, and you need to make sure that all of the routes are optimal between your data services and your applications to guarantee that you have the lowest possible latencies for what you're deploying, to make sure that everything is going to work as expected and that there's no surprises in your environment. We also have are now in the Murano app catalog, and so you can check out our trial edition today. That announcement was just went out. So how do we solve some of these fundamental problems? Well, first, we allow you to deploy, orchestrate, and govern a diverse set of workloads. And what I mean by diverse set of workloads is anything that could run on a modern Unix system. So OpenStack, it's great. It has a lot of different OSs and different things that you can deploy to OpenStack. But if you're using an image-centric model, it's going to be very difficult for you to have the portability to move it to these other cloud vendors. You're going to be stuck copying VMs and doing things that are slow and or possibly error-prone, or have security compromises when you're moving it to this new platform. We take care of that by having policy controls over all of these assets. So whether you're deploying a service or an application, whether you need resource constraints, whether you need to set up custom routes, whether or not you need to, whatever security implications you have, all can be described in our policy grammar. It has enterprise-grade Docker support with full multi-host networking built in. And you can move workloads because of our package management tier in a matter of seconds. And what I mean by package management is we actually understand all of the different dependencies that your applications and services need. We understand what OS it's running, what runtimes it's running, and exactly what it takes for your application to run. Therefore, we can do things like retiring packages. We can actually detect that the version of Java you have had an exploit and that should no longer be able to be deployed. That you should be able to have a seamless upgrade path to a newer version of Java that doesn't have those security problems and be able to actually integrate that with the lifecycle of your application. We also have service gateways that do secure service provisioning, whether that's Postgres services, MySQL services, Redis, MySQL, or your basic software as a service through mVariables and just basic URIs. We support gateways that secure those credentials. To give you a little bit more detail about that, we actually are binary protocol aware on many, many protocols, which allows us to not only control what services you can access from our system, but what level of access those services should be given. If you have a database table that contains credit card information, you probably do not want delete requests to happen on that database table. We can actually enforce that on the wire and guarantee that a delete request to that database will never actually get to the database. That's not me modifying the grant tables. That's not me going in and changing the security permissions within the service. It's us actually looking at that on the wire, seeing the frames for that delete request, and replying before the database even sees it, giving you a level of control and security that is not available in any other PaaS platform on the market. And we support those for Postgres, MySQL, Redis, Memcache, and HTTP with HTTPS promotion so that we can actually change those credentials and then upgrade you to HTTPS in a way that is actually truly secure. We also have a lot of open source at Apcera, and I wanted to spend some time talking about ways that we are part of this open ecosystem. First, we write a high-performance messaging system called GNATSD. It is capable of sending millions of messages per second and is in fact used by several areas in Wall Street and for mission-critical applications. This is the basis for our messaging backplane within our hybrid cloud OS. We use signed JWT tokens to guarantee that message delivery between different components have not been compromised, and we can guarantee that every message in the system is signed to guarantee that that action should actually occur, and that no one is actually forging requests in your system and making calls that shouldn't actually be made. The second is actually a slightly bigger deal, is that we just open sourced a product called Kerma. We worked very closely with the CoreOS developers on a new container runtime. And Kerma is a next generation containerized host, much like CoreOS, with containers all the way throughout the operating system. So it's a Linux system that boots a kernel, and then immediately everything in the system is a container. Whether that is NTP, whether that is your database service, everything runs in a container, and nothing actually sits outside of a container, providing complete silos for all your application and an ultimate security footprint. The next generations of our hybrid cloud OS are going to be based on Kerma, but the development is ongoing today. We also have Kerma OS images available where you can actually play around with this new operating system. It's all available on GitHub, and we've been working with CoreOS very diligently, and it is completely compliant with the app container spec. And we're the only third party that has actually written a full app container spec implementation other than CoreOS itself. And the last thing that I wanted to kind of describe is that we are hiring at Apcera. We're always looking for new dedicated developers. And we are, if you're interested in containers, scheduling, moving workloads, hybrid policy, network topologies, we'd love to hear from you. And then I wanted to kind of open up the floor to any questions that anybody had about our hybrid cloud OS or any of the offerings that I just described. Anybody? All right. So I think that's going to be it, if nobody has any questions.
Thank you.
Thank you.